Okay, this lecture is going to be on empirical formula. Now, empirical formula is kind of one of those things where it doesn't really make sense until you learn how to calculate molecular formula. So basically what I want you to kind of think about today is the procedure in developing an empirical formula. Okay, but before we get started, let's talk about something. Or let's define what empirical formula is. Empirical formula is going to be a compound that shows the smallest whole number ratio of the atoms inside of the compound. Okay, meaning if I have something like, I don't know, C2H6, okay, this ratio, 2 to 6, is not the smallest whole number, right? I can divide 2 by itself and get 1, and I can divide 6 by 2 and get 3. So the empirical formula for this would be C1H3, okay? So the empirical formula may or may not be the actual formula of the substance, okay? So let's find some more empirical formulas, kind of like what I did over here. Ethene. Is C2H2 going to be the empirical formula for ethene? The answer to that is no. Why? Because I can reduce 2 and 2 by dividing by 2. So the empirical formula for ethene is going to be CH, okay? For styrene, we can do the same thing. It'll be CH, okay? So these two empirical formulas are the same for two different actual compounds, okay? And we can actually find this information in the lab, and then we can use the actual mass of the substance to figure out what its actual formula is, like C2H2 or C8H8, okay? Can I reduce H2O down any further? I hope you said no, because 1's already down, and if I reduce or if I divide 2 by 1, it just becomes itself. So water is an example where the molecular formula, the actual ratio between the atoms, is the same as the empirical formula, okay? What about hydrogen peroxide? Can I reduce that down to an empirical formula? The answer is yes. Both of them can be reduced. So the empirical formula will be HO or OH. I'm sorry, I kind of wrote it backwards, but that's okay. Okay, so we actually use percent composition, which we learned yesterday, to find the empirical formula of a substance. So let's kind of take a generic example here. Can you tell me what percentage of red, green, blue, and gray I have? Okay, so go ahead and take a second and do that. Okay, so what you should have gotten was something like 12.5% for green, 12.5% for red, 25% for green, 12.5% for blue because it's the same amount as red, and 50% for gray. So what I did was, for example, for red, I just did 3 divided by 24 times 100, and that gave me my percentage. And hopefully what you realize is that 12.5 plus 12.5 is 25, plus 25 is 50, plus another 50. This is going to be 100%, okay? So we have a sample here that equals 100%. Now, let's think about, can I develop a ratio, right, like I did up here for my marbles, okay? And I can kind of think of it like this. I can say, well, I have 12.5 to 25 to 12.5 to 50, right? For every 12.5% of red I will have 25% green, okay? So if I was to divide by the smallest percentage here, which is 12.5, my ratio would be 1 to 2 to 1 to how many times does 12.5 go into 50? I hope you said 4, and that is our smallest whole number ratio. What that means is, for every 1 red I have, I'll have 2 greens. So for every 1 red, I'll have 2 greens. For every 1 red, I'll have 2 greens. For every 1, I'll have 2 greens, okay? And this is basically the empirical formula that we're going to do when we do these problems, okay? So if I was to, I'm going to skip forward down here. If I'm going to actually take what I just did with my marbles and apply it to a chemical composition, how would I do that, okay? So first of all, the one thing that I always have to do is assume 100 grams. I have to assume 100 grams because ultimately the percentages that I have to equal 100%, Okay, so let's look at a problem and how this works. So a compound is analyzed in the lab and found to contain 25% nitrogen, 74.1% oxygen, and the question is asking us, what is the empirical formula? Now you may be thinking, what? Okay, and you would be on the right track with that, okay? So I have a little thing that can help us remember how to do empirical formula, but we'll save that for tomorrow. For today's sake, to solve for empirical formula, I follow the same flow chart. I'm going to go percent, and I'm going to turn that into grams. Grams, I'm going to convert that to moles. Okay? And then I'm going to divide by the smallest mole, and that's going to give me a whole number that goes with that element. Okay, so let's look at how this works. So percent to grams. Okay, so I'm going to literally drop the percentage and turn it into a G. So I'm going to say I have 25.9 grams, and it says of nitrogen. Okay, I'm trying to figure out how many nitrogens I have, so it's not going to be a diatomic in this case. We're just going to make it an N. Okay, and I'm assuming 100 grams. That's why I can do that. And then I have 74.1 grams of oxygen. Okay, so that's my first step. Second step is grams converting to moles. So I'm going to say question mark, moles of nitrogen, question mark, moles of oxygen, equals, and I'm going to convert. Grams is on the bottom, so I want to cancel grams, so grams goes on the bottom. I want moles, so moles goes on the top. For every 1 mole of nitrogen, it weighs 14.01 grams. So then if I plug this into my calculator, I'm going to do 25.9 times 1, which is itself, divided by 14.01, and I get 1.85 moles of nitrogen. I'm going to do the same thing with oxygen. 1 mole of oxygen on the top, 16 grams of oxygen on the bottom. So I'm doing 74.1 divided by 16, and I get 4.63 moles of oxygen. Okay, next step, divide by the smallest mole. Who's smaller here, nitrogen or oxygen? Hopefully you said nitrogen, so I'm going to divide both by 1.85. So this becomes 1. 4.63 divided by 1.85 is equal to 2.5. Okay, now here's a little trick. I can't have a decimal subscript in a compound. Okay, it's just a rule. We can't do it. Okay, so I need you to ask yourself, what times 0.5 will give me a whole number? Well, you can kind of think about it like this. 0.5 is 1/2, right? So to get this into a whole number, I just multiply it by its reciprocal, which is 2/1. So this will then become a whole number. So that's exactly what I'm going to do here. I'm going to multiply this by 2/1, and whatever I do to one, I have to do to the other one. So I'm going to do 2/1, so this becomes 2, and this becomes 5. Okay? So with that being said, the empirical formula for this question is going to be N2O5, and that's your final answer. I realize it's a lot of work, okay, but it's very satisfying once you get an answer. Okay, let's try another one. Let's try, I'm going to skip this one, the A. I'm going to do B. I want you to try A once we're done with this notes here. Okay, so percent to gram. So I'm going to drop the percentage and change it to a gram. So I'm going to say 67.6 grams of mercury, 10.8 grams of sulfur, 21.6 grams of oxygen. Okay, grams then gets converted into moles, so I'm going to say question mark moles of mercury. Okay, once you convert all of them to moles, the next step is divide by the smallest mole, and you're going to get a whole number. Okay, So my smallest is 0.337. So I'm going to divide all of these by 0.337. So this is going to be 1. This is going to be 1. This is going to be 4. So the empirical formula is going to be HgSO4. And that's our final answer. Okay? I'm going to put number 3 up as an answer, and then I want you to try it. So pause the video now, and then play to see if you get number 3 right. Okay, this should be your final answer for number 3. We'll do some more practice in class tomorrow. Thank you.